Right, now let's make a function to actually print a string. So void print string const char star string. Right, so what we have here, we have a pointer to a character, to an 8-bit value. And what we'll do is we'll iterate that pointer, we'll increment it, and read all of these characters into video memory. Right, so let's create a uint8 pointer, char pointer, uint8 string, so that we aren't altering the address of this, we are creating a new value that we can change. And then we want uint16, our index, and then we'll set that to cursor position so that we can start writing at the cursor position. Now we need a while dereference char pointer, so we get the character at char pointer while it does not equal 0, so our string is going to be null terminated. So it's going to have a 0 at the end, and that's how we're going to know that it's finished the string. Now we'll increment char pointer, and we'll also increment index. And we need, before that, we need to dereference VGA memory plus index times 2. So we need to times it by 2 because in video memory we have one character and then one formatting value, and then one character and then one formatting value. So we need to do every second value. And we'll set that to the value at char pointer. Now, once we've done with our loop, we set cursor position index. And that'll put our cursor at the end of the word which is printed. Alright, now let's test that out and see if it works. So print string hello world. Ta-da! Now we can print a string or whatever at our cursor position very, very easily. But what if we want some string formatting? What if we want to do a new line format character or a return format character? So let's implement those. We'll start out with new line. So the value of a new line character is 10, so we can use that when implementing this feature. So we want a switch value of char pointer. Default is what we have here. Char pointer plus plus stays out of this. Just leave that as it is. And case 10 break, can't forget the break, and case 10 is index plus equals VGA width. Right, so every time it comes across a new line formatting character, it will go to the next line. Pretty simple. So let's test that out. We've got hello world and we've got the new line character. This is a new line. We'll compile that, run it, and as you can see, hello world, this is a new line. But it starts on the new line without going back to the start. Now to go back to the start, we need to use a return formatting character. And the value of that is 13. So we'll go back into here, and on the case that it's 13, we need to make index a multiple of VGA width. So to do that, we just need to index minus equal index modulo VGA width. Right, let's test that out. So we'll put the return character in, compile that, run it, and there we go. We've jumped to a new line and we've returned to the very left. Pretty simple. So now that we can display things to screen, let's set up a way that we can display values onto screen, like numerical values. So the first thing we need to do is we need to declare a char array, which is basically a buffer which we can store our string into. So hex to string output, and we'll set this to an array size of 128. Now we'll make a template function so that we can use this function for basically anything, and we only have to write it once. So template type name t const char star hex to string t value. And then we can return hex to string output. Right, so every time we call this variable, it will return a pointer to this array so that we can put it into our PrintString method. Now to actually get this function to work, we need a t star val pointer equals the pointer of value. uint8 pointer, we'll use that in a second. uint8 temp, which is a temporary variable we'll use for extracting the letters and numbers from the hex value. Then we have uint8 size. The size is equal to the size of t times 2 minus 1, because we need the amount of bytes and then we need to times it by 2 so that we can have one letter for each hexadecimal value, so to speak. And then we need to define I, which is just our index for the loop. Right, now onto the loop. For I equals 0, I less than size, I plus plus. Our pointer needs to equal uint8 pointer val pointer plus I. Our temp variable needs to equal the value at pointer and 0x f0 bit shifted by 4 bits to the right. And what this does is just extract the left part of the hexadecimal and gives us the value of that. So we can hex to string output size minus I times 2 plus 1 equals temp. And then to convert from a hex value to an ASCII value, we need to do this. Temp plus temp greater than 9 equals 55, else it equals 48. Then we can do the same with the other side. So temp equals 0f, so we have the right side and we don't bit shift it anymore. So now we have that loop. Right. Now, just to keep our string null terminated, we need to do hex to string output size plus 1 equals 0. If we don't do this, and then we print something big, and then we print something small, the array will still have the values of the old big thing, and then when we go to print it, it'll print the small thing, and then what's left of the big thing. So we just need to null terminate it so that doesn't happen. This needs to be plus 0. So we'll do new line and return print string hex to string 0x 1 2 1 2 3 4 a b c d. And as you can see, we have now printed 1 2 3 4 a b c d to our screen. So we've converted our value, which is a hexadecimal value. It's just a number, and we've converted it into an ASCII string that we can print to the screen. Now to do something else, we can print a new line, return, and then we can print a hex to string hi. Now what this will do might not be what you expect. It will actually print the pointer of the constant we have here. So the point in memory that this constant is stored at will be displayed onto our screen. So let's test that now. So as you can see, our constant hi is stored at the address 9025. Pretty interesting.